Good afternoon. We've all heard a lot about launch over the years, but very little about reentry. Why is that? Well, maybe because to date there have been 889 commercial launches and 53 reentries. Reentry has only been around slightly less than 15 years, and the catalyst for that was the NASA Commercial Cargo Program, followed by the Commercial Crew Program. And while that was the origin of the commercial reentry market, the future of the reentry market is so much more broad. Right now, there are programs in development for applications like logistics, manufacturing, human habitation, and R&D in space. And those items need to come back down to Earth. So we're going to talk today about reentry. So take it away, Manoli.
Yeah, absolutely. I don't know if we have the slide for just to show the visual. So my name is Manoli. I'm the Director of Mission Assurance at Varda Space Industries. Varda is a company out in Los Angeles, California. We build reentry vehicles for the on-orbit manufacturing of novel pharmaceutical formulations in microgravity. We have a separate line of business where we also test government payloads. There's significant interest in the areas of hypersonics. As you can imagine, a capsule reentering can go up to speeds of Mach 25. So there's interest there in understanding what that environment looks like. What you see on the slide that's up right now is images from our first 3 missions, 3 successful reentries. Our first one actually touched down domestically at the Utah Test and Training Range. And then we've actually been working with partners in Australia for missions 2 and 3, where we've done reentries into South Australia with our partners at Southern Launch. Right now, we're in the middle of our 4th mission, which is orbiting overhead as we speak. It's the first incorporating our own service module or payload module. Basically, we had previously partnered with Rocket Lab on the propulsive maneuvers after taking a Rideshare mission to lower Earth orbit. This is the first mission where Varda's actually built their own satellite bus and plans to do that on their own. For the purposes of this conversation, the thing that makes Varda a little bit unique is we do our reentry over land intentionally. So there's complications with that. And then we've also now got domestic and international regulatory things to consider. So we'll get into that as we move on.
Hi, my name is Collin. I'm the Vice President of Missions at Inversion Space. Inversion was founded in 2021 to fill the gap for delivery from space. So that's our primary focus going forward. We're currently just over 60 employees right now and growing pretty rapidly. We completed our first orbital mission earlier this year. We launched on a SpaceX transporter mission in January with our first vehicle called Ray. Ray's a fully vertically integrated system that we designed and built in-house at Inversion. We obtained our Part 450 reentry license back in October prior to the launch, and then Ray's been in orbit since its orbital injection earlier this year. We've had a ton of learning on this system, and we're using all of that to guide us going forward to our next vehicle called Arc, which will be our production system that we're unveiling in September later this year. So you can see in the slide image lower left is the Ray system. It's basically a capsule with a service module similar to what Manoli was explaining on his end. We also have a pretty similar mission overview, launch on a launch vehicle, separate in orbit, and then we use our propulsion system to bring us down into the atmosphere and then landing under parachute. The service module separates prior to atmospheric reentry, and then that burns up in the atmosphere prior to the capsule then landing on the ground. For this mission, we were able to complete, as I mentioned, a ton of really good testing. One of the most proud things we were able to do was in-orbit maneuvers. So we actually were able to lower and raise our orbital parameters as we were orbiting the system. And then last thing I want to mention, just showing the picture in the upper right-hand corner of the slide, we're able to take some really good images of Earth as we're orbiting around. Thank you.
All right, good afternoon, everyone. My name is Adit Rudrakshi. I'm the Associate Director of Commercial Spaceflight at Arctos Technology Solutions. So let's talk about Arctos a little bit. We've got over 40 years of experience doing spaceflight safety analysis for both the DoD and commercial industries. We develop, maintain, and continually improve a software suite that's used to show compliance to both RCC and FAA regulations. So what does that mean? It means our core tools have a capability of performing things like trajectory propagation for both launch and reentry vehicles, performing breakup analysis and computation of risk metrics, such as EC, conditional EC, and computation of hazard areas. Some of the more advanced capabilities of our tools are to be able to model things like overpressure and blast analysis, so that tells you what kind of damage you may cause to buildings, windows, things of those sorts for both launch and reentry vehicles. We also have tools that compute something we call maximum probable loss, or MPL, which basically prompts insurance requirements, and it helps the government or authority determine what kind of insurance is required for various operations, and other capabilities like toxic risk assessment. So, hey, you have a release of something on the ground, what happens, what are the risks associated with that, and how do you contain it? Next slide. So a topic that I want to bring up is a comparison of launch and reentry. So we're going to talk about this a little bit more down the line, and we're going to delve into this quite a bit as this is the focus of our discussion. But a couple visuals. So on the left side here, I have an image that has various ground tracks for first stages of launch vehicles launching out of the Eastern Range. And then on the left side, I've got a CST-100 hazard area and ground track re-entering into Utah test range, and a Dragon capsule re-entry track too. So what's not immediately obvious, because the images might be a little bit small, is the scale. So the re-entry ground tracks are about 5 to 7 times larger than the launch hazard areas and the launch ground tracks. And the image on the bottom right there really is it's the punchline, is you've got a high level of geographical variability compared to launch when you were discussing reentry. And when we start getting into lifting body and more novel type reentry vehicles that have high lift over drag capability, that variability increases even more, adding further complexity to reentry and reentry safety. So, thank you.
I'm Burton, Catledge, CEO and founder of Launch on Demand. We have 4 business lines. We do licensing for launch, reentry, spaceports, and satellites. We also do what we call day of launch or day of reentry services, which is basically all the surveillance and weather and requirements to bring either something to or from space safely. The third line of business is what we do, spaceport development. And the final line of business that we have is called Launch Integration Management Systems, which is where we take the payload and we assist the operator with integrating it with the launch vehicle. We've been in existence since 2018. We've had a variety of different customers, launch, reentry, spaceports. We've worked extensively with the FAA. We understand the challenges of regulations and 450. And so I'm happy to talk about reentry today.
Great. So Adit, you already started us off with the differences between launch and reentry. Collin, how do the public risks differ between launch and reentry?
Sure. Yeah, I think just to start it off, the obvious thing is vehicle size and propellant loads for reentry vehicles versus launch vehicles. Obviously, we need to sit inside of a launch vehicle, so we're definitely going to be smaller. In terms of an inversion spacecraft, we are orders of magnitude smaller, so basically a drop in the bucket for propellant and size of the launch vehicle. As we launch into space, our systems are fully inhibited from any hazardous events that we could cause, so kind of like basically a sleep state until we get in orbit. And then once we're in orbit, we'll kind of look at the energy state of the system. So here is where we're deployed, and then our inhibits are gone, and now we're fully loaded with propellant, and we could have hazardous events at that point. So what we want to get down to is the ground where our low hazards. We'll enter the atmosphere, our propulsion system will slow down the vehicle, come down to the atmosphere. Our risks, this is when our risk is highest, because if we have overburn, underburn, we can vary from where we would anticipate landing. But as we get through the atmosphere, we'll, as I mentioned before, on our system, we have a service module, so that separates, burns up in the atmosphere, and then we're left with just basically the capsule. At this point, it's a benign system. It can land under parachute or some other means, but now we're at our low energy state. So it's basically opposite of what a launch vehicle is, where we start off high risk up in the in orbit, and then as we're landing, we're very low risk. Overall, I think especially on our size, we're pretty low risk compared to launch vehicles, and then landing, of course, pretty benign at that point.
Yeah, I think I'll build on that a little bit. Adit showed that ground track. I think that's actually pretty eye-opening to see how large that in-track length can be, because imagine now, even in a nominal case, trying to give yourself the flexibility to be able to hit, we call them reentry commit criteria. Like before you perform your reentry burn, you have to hit a certain set of parameters before you can come in. And it's that balance when you're overflying land, specifically in Varda's case, to give yourself the flexibility to hit all your parameters and inputs and build that envelope around how you would perform a reentry, but then not let that get so large that you can't actually operationally constrain it. Because when you look at the Part 450 reg, it is, that we talk about possible but not probable. All those thresholds for risk, even in a low-risk small vehicle environment, when you're bringing it back, is going to be substantially large. Like Varda's first mission, I don't know, you probably find it on Twitter, but I think we hold the record now for like the largest NOTAM in the continental US, because like that corridor that we had to have approved was several hundred miles long, even though you know exactly where you're gonna touch down. Once you consider all the failure modes, the overburn and the underburn cases, and you hit those thresholds, it actually ends up being a really, really large area. So we'll talk about that a little bit later, I think, on how to find reentry sites, but it's definitely something to consider in the difference between launch and reentry.
What methods to determine and mitigate risk that are used for launch are not applicable to reentry? Adit?
So yeah, I'm going to tee a little bit off of what Manoli was just talking about in terms of the record for the largest hazard area. So that's a competition you don't want to win, by the way. That's not one that I think any of us want. But I think that's the biggest challenge, right? So we talk about location of launch sites. So typically, in the traditional sense, launch sites are fixed, whether they're domestic U.S. launch sites or foreign launch sites. For the most part, generally, launch sites are fixed. Now, think back to the image that I had presented with the ground tracks that basically process all over the Earth. Reentry can be anywhere. And that is literally one of the biggest challenges that we have, is that with launch, it's a known known. You know what your challenges are. You know if the vehicle blows up. There's some level of blast analysis, overpressure analysis you have to do, and debris risk analysis. But when we're coming into that capability, you want to have the latitude and capability with your reentry vehicle. Really, that's what reentry companies are providing their customers, and what they're providing the industry is capability. With that capability comes the challenge of coordination. So with launch, like we talked about, it's fixed. You know who your stakeholders are. You know who you have to go to coordinate, say, hey, we're going to launch at this time. Here's our hazard area. Here's our potential debris. With reentry, it's almost like you're chasing a moving target, right? So your mission parameters change while you're on orbit. Things may happen while you're on orbit. You've got to move and adjust to a certain contingency. Now, each one of those knobs that you're turning introduces a high level of variability, which introduces further complexity, essentially, between launch and reentry.
Then among among reentry vehicles based on their design, what is the big difference between an ocean impact and a terrestrial landing? Burton, you want to take that?
So at a high level, when we talk about FAA regulations and the technical equations that go behind it and the analysis, and once you kind of peel all of that back, the goal of the regulation is public safety. And in our world, the word public has a specific meaning that you don't want to hazard people who are not associated with the operation. From there, you can kind of break it out and you can say, well, where do people live? They live on the ground, they live in water, they live in the air, and now, in fact, they actually live in orbit. So you have 4 places where you have to watch where people live. Well, I don't think it's too much of a surprise to everybody. More people live on land than they do on water. And so as a result, when you're coming back to land, there's more population, hence more risk. When you're re-entering over water, however, generally people don't live on water, or definitely not in the same clusters that they do in land. And as a result, the risk is lower. And so particularly as a re-entry vehicle is starting to go through its development and operational cycles, it changes over time. But what doesn't change over time is that the population over water is always going to be less than the population over ground. And that's the key to all of the FAA regulations and how you have to comply with them.
Yeah, I'll kind of pick up on that too. At Inversion, our first flight was, our full trajectory was over open ocean, and even the landing was in the ocean off the coast of California. So while I'd say the process is a bit simpler because we are not going over land and there's not the population densities that land has, there were a lot of unique requirements that we had to go through. For instance, shipping densities. We had to do a lot of research and understand what kind of shipping lanes we were overflying and where we were landing. And then, you basically go through and do the same calculations as you would on land, but just for ships. And there's a whole set of different regulations that you need to comply with for ships. But yeah, so there's that, plus you have additional stakeholders. So you're working with the Coast Guard. You need to make sure that they understand your mission, how it's going to work, how safe it is. And in our instance, we were actually landing in a restricted military zone, so then we had to involve the Navy as well. So while I'd say the process of getting a license and landing in water is definitely easier than land, it does have its own unique requirements that can add complexity to that mission.
Yeah, I think you're underselling it. Like on your side too. Like I know land is like where the people live, but also you have to like track the ship densities month over month. Adit, you brought up the fact that the longer you're in orbit, maybe you're phased differently. You're not going to come in. How do you check yourself against population differences, ship density differences at different times of year? Like that's something people don't realize. Like you have to actually produce an analysis that covers you over potentially a large area, and then you get into that conversation again of like how big are these hazard areas going to be? For land, for Varda, it's been challenging identifying like a landmass that's large enough to actually allow a reentry like this to occur. For us specifically, like in a nominal mission case, you can say with high certainty through sim and now some flight heritage, like where, like propagate that trajectory to ground and where it's going to land. But the reality is, depending on the time of day, depending the orbital parameters of where you were dropped into low Earth orbit, all that changes. So you do the analysis months in advance, and then you hope that you've hit all those points along the way to still stay true to that analysis that you did. And then it's again that balance of how do I give myself a large enough operating envelope but not over constrain the operational side. And I'll say like one thing, adding on the you guys talked a lot about the ship densities and the water stuff. For air, it's slightly different because you have something called like a chance of a high consequence event, or basically like your EC, your expected casualty numbers. But like for a NOTAM in the air, it's a 97% containment field. So like any piece of debris that goes through the air, you have to consider, regardless necessarily of if it would have a high consequence outcome or not. And there are some energy levels associated with it, but basically you end up with like varying sizes between land, air, and sea, period, also to consider, and it's just like a lot overlaid on top of each other. So.
Speaking of E sub C, we have a question from the audience. For Adit, how do expectation of casualty figures differ and compare between launch and reentry?
So that's a great question, and it's a loaded question. It comes back to the point that I think I'm beating on here, is that reentry is very variable in terms of where it can occur. Another factor that directly scales into your expected casualty is something called probability of failure. I'm sure some of you have heard of that. Typically, the science and the math is changing a little bit, but first-time vehicles are very conservative, where they basically give themselves a probability of failure of 1. They say, we've never flown before. In order to be conservative, we're gonna say it's going to fail. And then I don't want to get too into the math, but what happens is you basically divide 1 over your full reentry corridor, the time associated with your reentry. Now, to answer, going back to land versus sea, let's forget geographically for a second. Let's just talk about land versus sea. So reentering on land, typically, as Burton mentioned, you've got people living on Earth, even remote sites, because your reentry vehicle traverses so much of the Earth that you're going to fly over populated areas at some portion of your mission. Now, it starts to become pretty complicated in how you choose your reentry site now, right? So you know what your probability of failure is. You kind of know the vehicle performance and what it's going to do, what it has to do with the physics and math in order to get from entry interface back down to the ground. So you have to pick those things strategically. Now, for first-time missions, and I don't want to speak for the regulators, they typically do recommend that you reenter at remote sites, and that greatly helps with the reduction of risk and reduction of E sub C. And something that we touched on a little bit, high consequence events or conditional expected casualties. So that's basically a condition that you're forcing a reentry vehicle, or modeling what would happen if a reentry vehicle were to, with the probability of 1, hit a very populated area. What's the actual casualty associated with that? So I'm not sure I quite answered the question, but typically with the way that EC is managed for reentry vehicles is different than launch vehicles. Since your launch site is fixed, you have the capability within reason to evacuate the area that would potentially be a high consequence area. So the way you control E sub C and the way that you manage your risk is very different between a launch vehicle and a reentry vehicle. But ultimately, I think, and all of us can probably agree with this in some way, shape, or form, is we're not trying to fly right up against the E sub C threshold. We want to build in some confidence, and we want to build in a little bit of tolerance too in how we're planning missions. So I'll leave it there. I don't know if you guys want to add anything to that, or.
Yeah, if I could add something really quick. So one of the issues we have with reentry vehicles is that we are missing one of the big mechanisms that launch vehicles have to reduce risk, and that's the flight safety system. So if you think of flight safety systems for a reentry vehicle, once you're in orbit, as I said earlier, you're in your high-risk state. So you could abort your mission prior to like the reentry commit criteria like Manoli was talking about, but once you get into the engine burn and you start to come back down, if you were to abort the mission due to a flight safety system abort, you're gonna underburn and then go somewhere else around the world and land there, or come in on a random reentry at some point later on. So, and then even taking it further from there, as you're going through the atmosphere, if you have a flight termination system, you don't want to detonate your vehicle, because then you're going to spread debris around your whole ground track. So it's a bit more difficult for us because we don't have that mechanism to work with. But then we kind of go back and make our vehicles so that we have higher reliability. We go to our system safety programs and use other mechanisms to make it safer and reduce the risk. But I think that's kind of one of the biggest differences on how we can reduce risk versus a launch vehicle.
Yeah, I think that was like super subtle in that like we still have to meet the reg and all those thresholds. So you have to consider it the same way in terms of like if you exceed a certain threshold, you're supposed to go and develop a high reliability flight termination system. But the point there is it doesn't effectively do what it would for a launch vehicle. It's very different because once you're on that trajectory coming in, you're coming in. So it's like you still have to meet the threshold and you have to meet the requirement, but the intent of it is not exactly one for one. So it's interesting. I think it's also another thing, an advantage we do have is even though, like Adit said, we're setting high probability of failure, set it to 1, just go through it, don't try to justify like why it wouldn't be anything less than that. We are inherently smaller. I think that's like the elephant in the room too, is like the Varda reentry capsule is like 1 meter in diameter. Like go wrap your arms around it, right? So from that perspective, you can take advantage of that and set a slightly higher probability of failure and still meet the threshold requirements. So that's been helpful for us because we can set that early on, and over time, now that we've had several missions, we can start peeling that back and bringing it down in size.
So what are the main hazards that you look at for landing?
So you have your nominal cases, which is like, obviously we have a capsule coming back, we jettison a couple components nominally, so we're trying to notionally get that for sure 100% within a test range. Burton said it earlier, we want to keep that population low. It's actually effectively needs to be 0, where you expect the capsule to come back, so that's a separate challenge. But then we also look at like neighboring operations. So when you're coming in and flying over a coast, for example, our second mission into South Australia, we kind of come over the coast. You also have to consider all neighboring operations, and not to get into the whole ship conversation again, but that's also part of it. We basically have to cordon off those areas. We publicly notify, we surveil areas where we would expect potentially a piece of the capsule or service module to come down, and we hold those areas closed throughout the entire duration of the reentry. So basically, our licensing period at Varda starts at approximately our -4 hours or so. So 4 hours leading into where you command the burn to actually bring the capsule back is when we start licensing it. At that point, we're monitoring not only the parameters of the system, but we're looking at the airspace. We actually have active, like you said, Coast Guard, looking at who's entered or exited the areas. Our flight area restrictions go up. So we're looking at all those things and making sure that nobody is in any of those areas as it relates to like the risk level and the final analysis. The nuance there is you only again have until you upload that burn command to do anything about it. So part of the agreement is like limiting that exposure window with the FAA. So like when are you going to do your final go, no go poll for saying that you can come in? Ours is at like, R minus 90 minutes or so. You get like your second to last pass basically before you're going to upload the command and actually bring the vehicle back. So then you actually have an opportunity on the next pass to look and make sure everything worked nominally and influence like your contingency operations if you have to take any. But basically, once you've sent that command, like Collin said, you're coming in.
So let's switch to the current regulatory environment. What regulatory issues have you found most challenging from a reentry compliance perspective? Burton?
Oh, there's so many. Let me try and only have 14 minutes. I'll start it with people and tools because that's typically where I kind of start these sort of things. Most of these gentlemen right here, they're breaking new ground when it comes to space. You heard earlier that Lisa talked about how many launches there have been versus how many reentries there have been. Most of the safety analysis that we have been based upon historical information, how rockets have, in fact, behaved over time, situations in where the public was put at risk because of a certain situation. And while we don't always understand how the rules came about, those are the rules. And as a result, we have a very small set of tool sets that we can use to get the right answer. Very few tools are available to those of us in the industry that are trying to do these computationally intense determinations. So the first thing I would say was the tools that we have are not keeping up necessarily with the industry. The second part of this is the people who are regulating it. The FAA will always get a shout out from me. What they've been able to do in terms of their relatively small group of folks is pretty heroic with the budgets they have. But the amount of commercial throughput that's going on right now is pretty significant. And so you have a very small group of people regulating an entire industry that doesn't really have the resources or the ability or the tools in order to do that. And then you take on what I mentioned earlier or at the beginning with lack of historical context. So a reentry vehicle is going to behave much different than a launch vehicle. And so to be able to find people who have the tools, the experience, and understanding in a relatively immature industry is a tall order. So if you were going to ask me, how do you improve it, you need to talk to the pioneers, the folks who are doing this for the first and the second time. You need to take off the regulator hat for just a little bit. You need to listen to what they have to say, the challenges they have to face, and you have to be willing to accept some of the solutions, even if they don't match exactly letter of the law for the regulation. The industry is growing and the regulation should grow along with it. I know that's not exactly happening, but industry has a vested interest in making sure that the regulatory environment is conducive to a commercial space industry. And so we're not adversarial at all. I think we want to help. So somehow, through some of the working groups that Lisa's on, some of the working groups that these gentlemen are on, we're getting there, but I don't think we're getting there fast enough.
Collin, do you have anything to add?
Yeah. So going through the 450 process with the FAA, I used to joke with them that our vehicle was the size of about 3 or 4 TPS tiles on the Starship. And those get shed every time that thing launches. But yet we still go through the exact same process as SpaceX for their vehicle. So you kind of see, you know, it's not the same scale. So as Burton mentioned, there's industry groups out there that we've been working with to come up with something that we're calling like a 450 light version, where you have a inherently low risk system. Maybe you don't need to go through that full process. While the regulations are a bit difficult to change, we're looking at different avenues, such as working within existing frameworks that the FAA has available, or even requesting the FAA to put out some advisory circulars that can help operators with, you know, low risk systems to streamline this process rather than go through the whole thing. But yeah, I'd say overall, you know, if with these low risk systems, I think it would be great if we had another method to authorize it without going through this entire process that really isn't the correct scale.
Yeah, I think I'll add one thing to that that's a little bit unique to Varda's application is 2 countries are involved in approving our reentry, right? So twice the regulator. At first we went in with a vision that maybe it would be, you know, unified, or maybe we'd only have to adhere to the regulations on the Australian side. But then you get the FAA talking and the ASA talking, and getting to an agreement was just not going to happen fast enough. So we effectively had to be compliant with both sets of regulations. So now what's been interesting is we've been granted a Part 450 operator license to re-enter the Winnebago capsule, and under that rule, a lot of the stuff that we submit to the FAA has actually been transitioned to pre-flight reporting, meaning we haven't approved means of compliance. We've gone through the reg, we've gotten all that approved in the methodology for it approved, but the timelines now for the FAA are actually much shorter because ASA doesn't have this equivalent vehicle to be like, hey, we're going to actually all approve all your means of compliance as well, so you're also going to be on a 30-day timeline. Like now, previously we were submitting things 3 to 6 months in advance for the FAA. Now we're like looking at 30 to 60 days, you know, and that's actually been really helpful for our cadence. That's great. It's been awesome working with the FAA on that. Now you got to get ASA caught up, and there's tons of stuff there. Like they're a much more novel space agency, right? They haven't been around as long as the FAA has, so they don't have as deep of a well to pull into to figure that out. But getting that alignment there has actually been relatively exciting. But when we talk about regulatory constraints, for sure, one of the things we're looking at, like how do we get, you know, the Australian Space Agency now to also agree to like a 30-day review timeline? You can imagine there's a challenge associated with that.
So I have one idea or one suggestion on this that I think the aviation industry has actually already adopted which is where they have designated authorities or designated entities that are certified in order to validate the analysis and the approaches, and ultimately it goes to the regulator in order to be able to certify it. The amount of experience that you need to have in order to do some of these analysis is pretty high end. You need to have at least a number of years of experience. And if you have that number of years of experience and you are offered a commercial alternative to work for a launch or reentry company, or you're giving the option to work in Washington, D.C. as an FAA regulator, I think the situation is pretty obvious. So it's going to be very difficult for the FAA to be able to attract and pay for the talent that is really needed right now in the industry. And so I think a reasonable compromise is do what the aviation industry did, which was they identified the requirements for an entity to be able to be a certifier, ultimately leaving the final decisions to the regulators. That way, the designated entity could scale to support the need, but not necessarily have to be, in Washington, D.C. or necessarily a government civilian.
So can I use this as an opportunity to pivot to safety element approvals and advisory circulars? Okay. So excellent point, Burton. And some of us actually came from aviation, and the opinion on DERs, QARs, and such is you're going to get a lot of different opinions if you ask different people about it. But I saw the need for it in aviation. So the aviation industry is quite a bit larger. Some of the metrics Lisa threw out, there's about 880 launches. The plane that we all flew on here probably has taken off and landed more than 800 times. You think that one plane that we flew on has done more than all of the launch and reentry operations in the history of space, right? So how do we get to what Burton described, right? It takes time to get to that point. You've got to build up data. You've got to be able to do the statistical math in a meaningful manner to get there. So we're on track to do that. And I did want to highlight some of the things that the FAA, Office of Commercial Space, offers and does to help industry with that. So one of the things that they offer is safety element approvals. And what that means is that anyone can apply for a safety element approval. A third party like our company or Burton's company can say, hey, we have a tool that meets this regulation. Let's verify and validate its performance together with the FAA and make sure that we have a repeatable tool and a repeatable process that gives you the right answer every single time. So once you get through that process, the FAA doesn't have to do a piecemeal type deep dive into everybody's different vehicle application and license application. They say, hey, this process to generate trajectories or this process to generate hazard areas has been verified and validated. So any of these operators can use this process and this tool, and we, the FAA and the regulator, don't have to deep dive into the results as much as we would normally have to if we're getting one-offs from different operators. So they are taking steps to move in that direction. One thing I do want to say, though, is that the resource constraints at FAA AST are very clear to a lot of us in the industry and probably external to the industry as well. So right now, there's a lot of focus on getting operators who have licenses and coordination resources from the FAA. I'd like to see more focus on safety element approvals, and I also mentioned advisory circulars too, in the FAA working with industry through things like the Spark, other trade organizations to generate that kind of content. Because I understand it slows us down today, it's more work today, but in the long run, as the industry continues to grow and scale, it helps everybody. It helps companies who are building these vehicles, and it also helps the regulators limit their liability and just resources that they have to put forward. Like in the aviation world, that's the way that they effectively use their resources, is through DARs, QARs, advisory circulars, safety element approvals, and things of those sorts. So 100% agree with that point that he made, and I think we're moving in that direction. I think some of us might just say that we wish it would come faster than it is. So.
One of the audience questions, and this is for Manoli, what can be done to encourage more companies to land in the US versus overseas?
Oh, wow. Okay. Yeah, so I think we touched on it a little bit earlier. Right now, there isn't a dedicated range that is large enough in the US to accommodate, like when we talk about these novel systems, they're going to inherently have large hazard areas. So one of the challenges, and this goes back to our first mission, is there was actually a misalignment between like our understanding of what we would submit to the FAA and then what the test range would also require us to submit from like a safety perspective. So one of the challenges has been, how do you find areas in the US domestically that you can match the requirements of the regulation to then also like all the local requirements or whatever that test range's requirements are going to be? Because you're going to have, let's say you go to a military range, you're going to have like a different set of requirements there versus if you, like what we do in South Australia now, which is a private company that owns like a large landmass. So unifying on that, I think, is a big step. And then the other part too is just how are you going to, from an environmental perspective, get that approved repeatedly? That's like been a challenge on the launch side as well. So bringing, you know, we do, I can't remember the caps, how many reentries we've done, but, you know, Varda wants to do like, you know, in the next year or two, we want to be doing like a reentry, you know, every couple weeks. How do you like scale to that level where you can actually close off an airspace in the US that would intersect and cut off a bunch of east to west commercial flights? That's like an extremely challenging thing to do. So that's an area that we're working on to try to get a unified regulation behind.
Okay. Anyone have an add-on?
I'll do one more actually real quick.
Okay, go.
The environmental piece is another part of it, right? So right now, environmental approval timelines are like, so you're looking at like 9 to 12 months to establish a new reentry site based on what the local environmental requirements are going to be. How do you get the clock moving on that? How do you get the momentum behind it? How do you get all the data if you're a novel reentry vehicle company to submit for that and get those things approved? Right now, it's like a little bit gray on how that would happen. So like a lot of the stuff that we do is trying to work to make sure that that gets unified as well.
So I think there can be a dedicated, we're working with people who are focused in on having a dedicated reentry site. One of the challenges is still how you define a reentry vehicle. In some cases, like Varda, it's a capsule. So aerodynamically, we kind of understand what's going to happen with that vehicle when they commit to landing. In other cases, you have winged reentry vehicles that actually produce lift. And that's kind of a different reentry. If you remember earlier, I mentioned that, you know, where people live is key. Well, if you have a large reentry area for a winged reentry, then there's a lot of people it's got to cross over. But if you have a capsule that is kind of being on a ballistic trajectory, then you can put it relatively down in the same spot. But the other part that it's not a segue. I think it's if you look at the statistics of the number of launches that occur at federal ranges, particularly at Cape Canaveral, Kennedy Space Center, and Vandenberg, we need more spaceports. And I think Congress has recently passed the bill that allows spaceports to offer infrastructure bonds to build up so that infrastructure. So we need more spaceports, we need more reentry sites, we need more areas, I want to say people where people don't live, but there are already places where people don't live. But this is a valid mode of transportation. It's going to be necessary for U.S. commerce as well as for national defense. I just don't think that from a resourcing side, particularly on the ground, that it's gotten the attention that it really deserves. But we need more spaceports. I'd much rather Varda come down to the United States than have to go, you know, somewhere else, because if they're doing this once or twice a week, you know, I'm sure nobody wants to fly to Australia once or twice a week in order to pick up a thing, right? You'd rather just take a drive.
Okay, one final question, and that is, we have, within industry, we have collaboration, developing voluntary consensus standards, working together in the rulemaking committee to try and submit recommendations for improved regulations. what other initiatives are taking place within industry to improve reentry. Collin?
Yeah, sure. So one really good example is based on the flight safety systems that I talked about earlier. I think all of us reentry operators kind of came to the conclusion that this didn't work for us pretty early on. And then SpaceX was great and kind of got the group together, figured out, what recommendations we could make to the FAA and how we could come to a way around this issue. FAA was also got involved a little bit later on and really was receptive to our comments and what we were suggesting to move forward. So it's like starting with waivers in the near term, we could get around this issue doing a waiver for each launch, but then really looking downrange in the future, what do we need to change in the regulations to help reentry get around this? So I think that's kind of a really good example of how, as the industry, even though we compete in a lot of this, we're able to get together and really come across some of these hurdles.
Anyone have anything to add?
Yeah, I can add a little bit to that. So in addition, and Lisa, you hit on some of the committees and organizations that include both the government and industry getting together, discussing these types of topics, because ultimately we all want to be successful in space. I know we're focusing on reentry, but collectively we all want to be successful. So the FAA has done a great job actually of engaging directly with industry in open forums. So they do a weekly, what they call flight safety analysis office hours, and it's an open forum for industry to ask highly technical, high-level questions, whatever they want to ask to the regulators at the FAA. And it gives everyone a chance to hear those answers singularly, so things aren't being done in serial, or you're not having to wait your turn to ask your question in a line at a specific meeting with the FAA or such. So in the spirit of wanting to get there and wanting to get to where we need to be, like Burton said, the regulation still has a ways to grow. It's still in its infancy. That's one of the things that we really appreciate, that in industry, being able to sit down together in that open forum and get our questions out and have open discussions with industry and regulators. So.
Thank you, everybody. Hope you've learned a lot about the reentry industry and the things we're doing to make it more normalized within the regulatory structure. Thanks.